Hi everyone, today we will be discussing the chemistry of coffee. This presentation is for a Chem 120 lab. So what is coffee? What do you think of when you hear coffee? I usually think of waking up, maybe a boost of energy or breakfast. Some may think about caffeine and what it does for the person. And then although what you may think about coffee and its basic functions may be true, the chemistry of coffee goes far more in depth than one may think. Coffee is composed of many components that make up the composition of the coffee, which can be altered very easily through the brew's manufacturing process. The process of harvesting coffee. Two of the biggest factors that affect the composition of coffee are the harvesting and roasting process. Coffea plants are harvested for their fruit called coffee cherries. This then undergoes the process of fermentation, in which the top layer of the coffee cherries is either dried off or removed from the bean, resulting in the green coloration of the bean, and is given the name green beans. The green beans are then put into the roasting process, in which more chemical reactions occur, the first being the Maillard reaction, and I will go over this in the next slide more in depth. But following the Maillard reaction is caramelization. This usually occurs at around 170 degrees Celsius and higher, and is responsible for the dark coloration of the coffee beans. The Maillard reaction. The Maillard reaction is a series of chemical reactions that occur in the coffee beans when the roasting process begins. This usually happens around 140 degrees Celsius and higher. And this reaction occurs between a reducing sugar and an amino acid. A reducing sugar is any sugar that contains an aldehyde group or a ketone group. Both of these groups contain an oxygen atom double bonded to the carbon atom, and this allows for the reaction with amino acid. An amino acid has an amine group on one side of the structure and a carboxyl group on the other. The amine group is what is responsible for being part of this reaction. And this happens because the amine group has a nitrogen that bonds to the carbon chain in the reducing sugar, this resulting in a molecule of water being given off. From this process, glycosylamine, which is unstable, is produced. Glycosylamine has to undergo another structural change known as the Amadori rearrangement. Then following that, there's three more potential reactions that it has to undergo, which is either losing more water molecules to become more caramel type molecule, either that or it breaks down into shorter chain molecules, and there's another possible reaction path that it takes where it reacts again with more amino acids. This results in products available to react with amino acids forming melanoidins. Key components that affect coffee's characteristics. Coffee has many key components that affect the characteristics of each brew. Alkaloids being the first. Alkaloids present in coffee are caffeine and trigonelline. This affects the bitterness of the brew, and the reason for that is they are very bitter in their original form. Trigonelline usually decomposes at around 160 degrees Celsius, and this contributes to the aromatic compounds of the coffee during the roasting process. Volatile compounds, these usually evaporate at room temperature, and that's what's responsible for that smell of the coffee after the roasting process. So what you served in front of you, now you can smell it. Acids, these help balance the sweetness and the bitterness of the brew usually. And then there are lipids. These contribute to the texture of the brew, so the frothiness, the foamy. Frothy usually comes from milk, but how thick it is, how watery it is, that usually comes in play. There are more compounds in coffee. These are caffeine, which is a main alkaloid that's present. I will get more in depth about caffeine. Antioxidants such as chlorogenic acids and melanoidins are present. They usually help deactivate oxidants and can have certain health benefits for the drinker. Diterpenes, these are naturally found in the oil of coffee. Common diterpenes are cafestol and coale. These can potentially protect you against some cancers. And then there's mycotoxins. These are usually found in coffee. The ones that are usually found in coffee are ochratoxin A, acrylamide, and furan. All have been found to be a potential health risk, but none have been found to be carcinogens. What is an alkaloid? An alkaloid is a compound that contains at least one nitrogen and has physiological effects in the human body. Some examples of alkaloids are morphine, caffeine, and nicotine. Those are some of the most common. Caffeine is an alkaloid present in coffee and has some psychological effects on the human body. I also included, if you look into the bottom right of the presentation, that is the chemical structure or Lewis structure of caffeine. The chemical formula is there as well. The effects of caffeine on the human body. Caffeine affects the human body in physiological ways. It can increase motor activity, and that causes more alertness, activity, and restlessness. It is also possible to overdose on caffeine, and it can cause dizziness, vomiting, and confusion. And then you can also experience withdrawal from caffeine. So these symptoms, I'm pretty sure most know, but also include drowsiness, irritability, headaches, anxiety, and you can also have tremors from from withdrawals of caffeine. There are some nutrition facts and health benefits of coffee. For nutrition, coffee doesn't have any significant amounts of macronutrients, fats, proteins, or carbohydrates. It does, however, have micronutrients like niacin, potassium, and magnesium. And then coffee is 95% water, which helps contribute to daily fluid balance. All of those facts are true for black coffee, but can be altered due to dressing up coffee with the addition of sugars, creams, milks, etc. There are health benefits too. There's a potential to live longer. You're less likely to develop other certain diseases and cancers, and your body may produce glucose better. And there is a chance that your DNA will be strong because dark roasts do decrease breakage of DNA strands. Then why is chemistry of coffee important? The chemistry of coffee is important to many people and businesses, such as industry, for yourself, and for the list of farmers, harvesters, transporters, processors, roasters, and baristas. For industry, it's good to know how to manipulate the components of coffee, and it's a good way to increase business. You don't want to produce only one kind of coffee because a better way to spread your brand around and have more consumers is by having a great variety of coffee. For oneself, it's good to know the health benefits and correct consumption rates so you can avoid potentially overdosing or reducing those withdrawal effects if you drink mass amounts and then quit, go cold turkey. And then for that list of occupations that I said, it's good to know the chemistry of coffee to truly excel in your work and earn a proper living. Without understanding the processes and procedures, their businesses may not flourish as they would like them to. And that is really all that I have for the chemistry of coffee, and I'm glad you guys joined me today. Thank you.